A confidence interval of two independent proportions gives an estimated range of values, which is likely to include the difference between the two true population proportions for two categorical variables. Calculation of the confidence interval consists of three steps: conditions, calculations, and the conclusion. There are three conditions we need to check, the first of which is the random condition. The data in each group should be drawn independently and at random from a homogeneous population or generated by a randomized comparative experiment. The second is this 10% condition. If the data was sampled without replacement, each sample should be less than or equal to 10% of the population. The third condition is the success and failure condition. Both groups should be large enough that there are at least 10 successes and 10 failures observed in each group. Since we don't know the true population proportions, we use the actual number of successes and failures measured in our sample, which is why the result is expressed in whole numbers. This condition is calculated using the following formulas, where n is the sample size, p hat is the proportion, and q is 1 minus p. It's np is greater than or equal to 10, and nq is greater than or equal to 10. Be sure to calculate successes and failures for both samples. The confidence interval is statistic plus or minus z star times standard deviation of statistic. The z star depends on the specified confidence level, which in our case is 95%, so it's going to be 1.96. Now we need to find the standard error, which is the estimated standard deviation since we don't know the population parameters. We interpret an interval calculated at a 95% confidence level as we are 95% confident that the interval from blank to blank contains a true difference between the two population proportions. To this on a calculator, you want to go to tests, and from tests, go into two proportion z interval. From there, you'll be asked to put in your x1 value, your n1 value, your x2 value, your n2 value, and then your confidence level. So in our case, it was 70, 175, 150.95. When you press calculate, you get your confidence interval. Some common mistakes you could be making is using a two-sample t-test and not a two-sample z-test. Remember that a z-test is for proportions or categorical variables, while a t-test is for means or quantitative variables. Another mistake is that you are not checking your conditions for both sample groups, and make sure you check them individually. A third mistake is not noting your conclusion in context. The easiest way to do so is just to restate the question. And lastly, make sure that you are saying that you are 95% confident and not that there's a 95% chance or a 0.95 probability. Here are some quick tips to help you when you are trying to find these confidence intervals. So first is that using a calculator will definitely help you save time. But if you do, make sure that you show all of your work by writing down the z-star and how you got these sample statistics, like the different proportions and sample sizes. Doing so will make sure you get all your credit on the do section. Another tip is that if you don't remember how to solve for a confidence interval, or if you don't have enough time, then just make one up and write a conclusion based off that to earn as many points as you can.